the end. Looking here, that's just to solve linear systems. So there's a couple ways to solve linear systems. You can solve by elimination or by substitution. If they want you to solve by substitution, usually one of these would be something like x plus 3y equals 10. And so then you could just let x be by itself, and that would be easy for substitution. Or they might even start it out to be like x equals negative 3y plus 10. These are obvious keys to doing substitution, okay? In this case, none of those look like that, so we're going to actually do elimination instead. It's going to be easier that way. So this is stuff that would be good for substitution, and the one that we have is good for elimination, so let's go ahead and do that. Alright. I'm going to go ahead and just rewrite this out, make it easier. Now, if we're looking at this, to do elimination, you want to find two that are very similar. So, if I look at the 5 and the 7, you could do that. You're going to have to multiply both of them to be different numbers, which in this case would be 35, what they both go into, and then work from there. And you can do it, you're going to get the same answer. I had someone in one of the reviews do it. But the easier one to do is to multiply the second one, the 2y, by 2 to get it to be 4, get those to match, and then cancel. So to do that, I'm going to take everything here and multiply by 2. So I do that, and I now get underneath 14x plus 4y equals 10, okay? And I also have this minus 5, this minus 5x plus 4y equals 29. And you'll be like, what's going to happen here? What am I going to do? Well, it's actually easier if we're going to be subtracting these, okay? Really what I should have done was wrote it underneath, which I can still do, so let's kind of ignore that for a second. So 14x plus 4y equals 10. I'm going to go ahead and subtract everything here. So subtract all this. So minus 5x minus 14 is going to give me minus 19x. And then I have 4y minus 4y, that's going to cancel, no y's. 29 minus 10 is going to give me 19. Cancel out my y's, that's what I wanted. I'm going to divide now to get x by itself. X is equal to negative 1. So I got one of my x's. To find my y, I go back to one of the two originals, either one, and I plug in x and I find my y. So I can go to either one of them. Let's take the first one. Okay. So I'm going to plug this in for x, negative 1, to find y. Plus 4y equals 29. So negative 5 times negative 1 is going to be positive 5 plus 4y equals 29 minus 5. Just solving for y at this point, nothing serious. 4y equals 24. Now I just divide. And I get that y is equal to 6. Now, some professors are cool with leaving them like I did, circle. Some really want you to go ahead and take these, put them together, and make a point. So really, what this all comes down to is this is where these graphs where these equations on a graph intersect, and they intersect at the point negative 1, 6. So sometimes they like you to write like that, sometimes they don't really care. Kind of up to the professor. Yeah. And you should know by now which one you have, what they like better. Alright, now number 17 is asking us to solve for y. This is an absolute value problem. Now if you remember with absolute value, whenever you do these, you are going to get two answers. A lot of students say you're going to get two answers, one's negative, one's positive. That's not always the case. Sometimes you can get two positive answers, you get two negative answers. But how you started off is that one is going to be equal to a positive, one's going to be equal to a negative. It doesn't mean it's going to stay that way, okay? One thing your professor might try to do is if I gave you a problem like this, where in the beginning it was equal to a negative, you see how it starts off with the bars, the absolute value bars are still there. These are always no solution. So that's a trick. Teachers like to fool. Please be aware of it, okay? In this case, we don't have it in our original problem, so how I do this is I have one positive, one negative. 2y plus 31 equals 15, and 2y plus 31 equals negative 15. Notice the signs with the 31 and the 2y, none of those change, only the signs with the 15. Now I just go ahead and solve like I normally would, so minus 31, 2y is equal to negative 16, Then I go ahead, I get divided by 2 here, and I get y is equal to negative 8. That's one answer. Over here, minus 31, minus 31. 2y is equal to negative 46. Divide by 2, and I get y is equal to negative 23. Notice both answers are what? Negative. They started out with one is negative, one is positive. Like I said, it doesn't mean they're going to stay that way, okay? And I'm finished with this problem. Look at the next one. The next one is asking us to simplify this. Okay, whenever we're simplifying this, one thing we need to know is whenever you have exponents being raised to a power, so they're being raised to that power, you're going to multiply your exponents together. So what am I talking about? Well, I have minus 2x cubed over y to the 7 to the third, okay? Now this 2 and this 3, I'm just going to take this as negative 2x to the third power. I'm not going to multiply anything, okay? So it's going to become negative 2 to the third power, sorry about that. Alright, now this 3 and this 3 are going to get multiplied together because I'm raising it to a power. So on the 3 times 3 is 9, so I get x to the 9. On the bottom, the 7 and this 3 are going to multiply together. I get y to the 21, okay? Negative 2 to the third power, remember if you're having negative number, cubed, fifth, 7, odd powers, okay? It's going to stay negative, so I get negative 8, x to the 9, over y to the 21. That's my answer. I can't cancel anything, I can't simplify anything. I'm finished. Alright, let's look at the next problem. The factor by grouping. Factor by grouping, it'll always tell you it's factor by grouping. There's no tricks, there's no surprises here. You also usually have 4 things. There's no way you can factor by grouping if you didn't have, at least 4 things here. Anyway, okay? Alright, so how it works is I want to look at these 2 separately, see what they have in common. Look at these 2 separately, see what they have in common. I factor out what they have in common. I should get the same answer, like x plus 1 or something, okay? On both of them. So let's go ahead and do it. So the first one, I'll stick with the blue. I'm looking at this. They both have a 4 and a 14. Take out a 2. They both have a y. Take out a y. What's left over? Well, in the first one, I'm left with a 2x, okay? And the second one, I'm just left with a 7. So 2x plus 7. In this next one, I better get 2x plus 7. If I don't, something went wrong. I need to go back and look, see what I'm doing here, okay? So I notice these are both negative. Well, this is all plus down here, so I have to take out a minus. 1035, we'll take out a 5. And then what's left over? If I take out a 5 in the front, I get 2x. Take out a 5 in the back, I get plus 7 because I took the negative out to change the sign. If you ended up with a minus, you still have to take a negative out, okay? Now that these are the same, I know I did it right. So what I'm going to get is I'm going to get 2x plus 7. It's just going to become 1. Just one of these. And I'm going to combine together those 2 things into one parentheses. So 2y minus 5, like that. I've now done factor by grouping. I'm finished. That's my answer. Don't have to do anything else. Okay, go ahead and move on. Okay. Now this next one is asking us to graph, and the next one's asking us to solve the system. Okay, so graphing, if we look at this, this is 3x minus 4y equals 12. What do you notice about this problem? What's 3 times 4? 12. Okay? There's certain problems where your teacher wants you to do the intercepts. So if they want you to find the x and y intercepts, they're going to give you something like minus 2x plus 3y equals 6. What's 2 times 3? 6. Stuff like that, okay? Where they're going to multiply together. So to find the intercepts, let's do it. Alright, find the x-intercept. I let y be 0. So I get 3x minus 4 times 0 equals 12. Basically, I don't even look at that. So 3x equals 12. Okay, divide by 3, divide by 3. X is 4. So I know this is the point, 4 comma 0. I know that. I found that x was 4. Y is going to be 0. Now let's find the y-intercept. This is the case where x equals 0, alright? So I get, let me do it down here, 3 times 0 minus 4y equals 12. Again, I ignored that. So minus 4y equals 12. Divide by 4. Divide by 4, negative 4. Y is equal to negative 3. So this is the point. 0, negative 3. Now, I go ahead and put these dots on the graph. Okay? So here's my x. Here's my y. 2, 3, 4. That's 4 comma 0 for the first point. This point, the second one, is this is y, go down 3, right there. Negative 3, connect my dots. There's my graph. I don't have to find any other lines. Okay, this next one here is asking us, solve the following system using the graphical method. Remember, I told you earlier with the systems of equations, it's where they cross, where they intersect. So, where do they intersect? What's this point? Well, it's kind of hard to see in this format, but on the actual paper test review, this is 1, and this is 2, so this is literally the point 1 comma 2. Simple as that. I'm going to stop here and then finish the next two. Finish next.